I don't know why it made that noise yesterday, didn't it? That was weird. Rose curves were one of the curves that you kind of got to explore in the Desmos lead-in activity for polar graphs. And it's called a rose curve. It doesn't look like a rose, but it does look like a flower. It's got like these petals. The format of the equation for it to be a rose curve looks like this. You've got R equals, and then it's A times sine or cosine of n theta. So now it's not just theta inside the trig function. There's a coefficient, an integer coefficient. It says here that n is an integer greater than 1. Okay, so if there is some coefficient there, not just an understood 1, okay, that's going to change this shape. It wouldn't be just a circle like a sine of theta is. The activity where you got to play with the little slider on there, you may have noticed this when you kind of jotted down some notes as you were going through it. But the number of petals is determined by that n value. And you may have noticed when you went through it that if the n value was an even number, then you had 2 n petals. Okay, so whatever, come in. Yeah, you can come sit and take it. So when you have an even n value, you multiply that by 2, and that's your number of petals. Okay, when it is odd, you're doing the test, right? Yeah, that's the test. Okay. You can come grab this. You should see it in Aware. Let me know if you don't. Okay, sorry about that. So we've got when n is even, you double it, and that's how many petals you have. So here there's 4 petals on this rose curve, so n was 2. Okay, there are 8 petals on this rose curve, so that means n was 4. Okay, now these have an odd number of petals. That means that their n must have been an odd integer, and that's how many petals you have. You don't double it if it's odd. So this, there's 5 petals, so n was 5. There's 3 petals, so n was 3. Are y'all with me on that? So we're going to jot some notes down, then we're going to come back and look at those pictures in just a second. Okay, so if n is odd, there are n petals. If n is even, there are 2 n petals. Okay, and that's the coefficient there. That's your n. And that determines the number of petals on that rose curve. Okay, the a value, the coefficient in front of the trig function, determines the length of those petals. Okay. And then the trig function itself, whether it's sine versus cosine, is going to determine where the first petal aligns, at what angle. Okay, so sine versus cosine. If it is a cosine graph, cosine, when we were doing circles and lemniscate, or excuse me, limicons, we said if it was cosine, it was drawn along the x or the horizontal axis, right? Okay, that's going to be the same thing for a rose curve. If it's a cosine rose curve, the first petal is going to be drawn on the polar axis or at 0 degrees. Now, if it's a sine one, it's going to be rotated. The first petal is going to happen at 90 divided by n. Okay, so whatever n is, if it's a sine graph, you'll do 90 degrees divided by n, and that's the angle where the first petal would be located. Now, the spread of the petals, how far apart the petals are, they're equally spaced. So how many degrees is a rotation around one full rotation? So if I want to equally space my petals, I'm just going to do 360 divided by the number of petals. Okay, and that will even, the first one starts at 0 or whatever this comes out to for sine. Okay, and then you space them out by however much that is. Okay, so in these 4 images up here, what would be the A value for this first one that had 4 petals? 2. The length of the petal from the pole to the tip of the petal is 2. Okay, what about this one that has 4 petals? Or excuse me, N was 4. It has 8 petals. Also 2. Okay, what about this 5 petal one? And the 3 petal one? Also 3. Okay, so these petals were 3 units long. These petals were 2 units long. Can you tell me which of these are cosine rose curves? Bottom right. Okay, so this one has a petal on the polar axis. Good. And this one does as well. We know that these are not cosine because there is not a petal on the x-axis or the polar axis. So these were sine curves, rose curves. Feel okay about those? All right, so we're going to try a couple. We're going to graph some. Yes. Yeah, it could be. It depends on how many there are and where it started, if one ends up there. But you can definitely tell that these are not cosine if there's not one. All right, so let's try graphing this r equals 2 cosine of 3 theta. Okay, so this would be, oops, wrong color. Cosine in green. Our n is 3, and our a is 2. Okay, so I'll start with n is 3. That's odd. So that means there's how many petals? 3 petals. Good. Okay, this is a cosine curve. So that means that the first of those 3 petals is where? Okay, the spread of the petals, the first one is at 0, and then there's 3 of them. So I would do 360 divided by 3. So there's going to be 120 degrees between petals. Y'all agree? And then the length of the petals is what? All right. So when I go to graph this, start at 0 degrees at 2 units out. That's the tip of the first petal. And I'm going to rotate 120 degrees. That will be the tip of the second petal. And I'm going to rotate 120 degrees. And that will be the tip of the third petal. Okay, and then of course there's the center, the pole. Okay, now how you sketch it doesn't really matter. We will look at these in the calculator later. I don't know that we're gonna have time today, but on Tuesday when we come back then, we'll look at graphing these in the calculator, because then you can watch it be drawn. You can watch it trace out and watch the path that it follows. But when you are sketching it yourself, it doesn't really matter. Just make sure that you're not doing points like at the ends of the petal. They're not pointy. Okay, these are curves. Okay, so if I start here and I curve around to that, and then I curve back in, then it's out to this one and back in, out to this one and back in. So something kind of like that. Now, my drawing is not perfect. We just are sketching it. We know the general shape and location and size, but I didn't draw these all these petals perfectly the same width, which they should be technically. They would all be the same width and size, because I was just kind of freehanding that. I only had 4 points plotted, so it's okay that it's not perfect. Yes. What do you mean when it oh, the concentric circles of the grid? Yeah, the first circle is 1, the second circle is 2, 3, 4. Yeah, the grid is just made up of concentric circles. They're all evenly spaced. If it is not labeled, you assume that it's scaled by ones. Good question. Feel okay about that one? Okay, let's try this one. Okay, A is 3. This one is a sine curve, and N is 2. Start with the number of petals. Since N is 2, how many petals will there be? Because that's even, right? You double it. So 4 petals. Okay, where will the first petal be? Because it's sine, the first petal is at 90 divided by N, which is 2. So it's at 45 degrees. Okay, so then the spacing of the petals, how many petals are there? So we do 360 divided by 4. So there's 90 degrees between the petals. All right, and then A is 3 here, and that is the length. Of the petals. So when I go to graph this, starting at the pole, I'm going to go out at 45 degrees. I'm going to go 3 units out. Okay, and then I'm going to rotate 90 degrees. That's going to put me at 135. And I'm going to rotate 90 degrees. That's going to put me at 225. And I'm going to rotate another 90, which would put me at 315. So again, the direction that you go to sketch your petals doesn't really matter so much. If you want to do one petal at a time and then do the next one and then the next like that, I don't care that that's how you draw it. That's not actually the path of the curve, but you can't tell that when you look at the final product. Okay, we will be able to tell the actual path when we watch these being graphed point by point in the calculator. Feel okay about rose curves? All right, so then the last shape we're going to talk about is called it's pronounced lemniscate. Okay, and it looks similar, the equation looks similar to the rose curve equation. because there's a 2 theta inside the sine or cosine function, okay? But there's not going to be 4 petals. This is a different equation. What is different about it? You see the squared value. It's not r equals, it's r squared equals. If you do see it as r equals, if you ever see it as r equals, what would change? What would this look like over here? Yeah, you'd have a square root over the rest of that, which is fine. You can write it that way as well. That's just as accurate. Okay, and it's not in theta. It's always a 2 for a lemniscate. It's always 2 theta. Okay. So you can rewrite the other one as well if you want. Now, it's got some similar properties to rose curves. It does have petals, okay, but there are always only 2 petals, okay? And if there's only 2, I don't know why this is on a second page. I should have drawn this on the same page. So I'm going to come back to those pictures in just a second, okay? But so some of this stuff is the same. The A value is still the length of the petal, just like in a rose curve. However, because there are always 2 petals, the shape is always the same. If it's just 2 petals across from each other, what would you call that shape? It looks like an infinity or a figure 8. Okay, so it's a figure 8 shape. The A is the length of the petal. Now the sine and the cosine still determine the direction that the petals, the angle that it's drawn at. So for your cosine graph, it's always at 0 degrees still, just like the rose curve. Okay. And if the rose curve was 90 divided by n, and this is always a 2 in that place, this is always going to be drawn at a 45-degree angle for sine. If there's only 2 petals, what is always the rotation between the petals? 180 degrees. Good. Does that make sense? So I'm going to sketch back up here on these grids. I'm going to sketch a cosine and a sine one, but they don't give us a specific problem here. So we can pick how long we want the petals to be. We'll just make it fit in this grid. So I'll just use 3. So I'll just come out. Oh, hold on. This first one is sine. So it needs to be at 45. Then in the opposite direction there. Okay, so it would just, you just make a figure 8. That's a lemniscate. That's a sine. If it's cosine, goes along the polar axis. So far, so good? All right. Let's try these 2 examples then. Now, what you need to be careful of is that the formula or the format of the equation, it's not a sine of 2 theta. What is it? A squared sine of 2 theta or cosine of 2 theta. So that coefficient in front of sine or cosine, that's a squared. So when it's written this way, that is not your a. That is your a squared. So a is what? 4. Okay, and then this is a, I'm sorry? Yeah, because we were just talking about the length of the petal. We're not worried about positive, negative there. All right, and then this is a sine lemniscate. So what angle is it going to be drawn at? At a 45-degree angle. Okay, so when I go to sketch this, At 45 degrees, I'm going to go 4 units out because that's the length of the petal. There it is. This one is cosine. So it's going to be drawn at 0 degrees. Your a squared is 4, which means a is 2. So this one's going to have a shorter petal, only 2 units out. Feel okay about those? All right. So we're going to do a little check for understanding in... Actually, before I do that, I do want to point something out on Desmos. Okay, so in Desmos, when you go to just like the home graphing, this is what it looks like. If you want to graph polar equations, you need to change your grid from rectangular to polar. To do that, you go to the tools here, the graph settings, the wrench, and under grid, the one with the squares is highlighted. Here right next to it is the circles, the concentric circles. That's your polar grid. So change it to a polar grid. You can, right now it's in radians. So you can see the angle measures are labeled in radians. You can change to degrees if you're working in degrees. So you can change back and forth there. Okay. The only thing is when you go to graph, you can graph the curves, but you can't just plot polar coordinates on here. If I try, because polar coordinates are in the r theta. So if I tried to plot a point at like 2 pi halves, notice it puts it right here in quadrant 1. It's plotting it as a rectangular point. It's going over 2, up pi halves, which is half of 3.14, right? It's plotting it as a rectangular point. So it's not going to plot it correctly at the pi halves angle 2 units out, which should be here. Okay, so unfortunately you can't plot points, polar coordinates in Desmos. It doesn't work. But you can plot, so you have to use r and theta. Don't use x and y. Okay, so I could say if I wanted to do a rose, I could type that in and it graphs the rose for me. Okay, if I wanted to change this to a lemniscate, I could make that squared. That's 16. Oh, I guess they won't let me do it as r squared equals. I'll have to type it as the square root of this. Oh, oops. There it is. So you can type it that way to get a lemniscate. We could get our limicons, which were in the form of a number plus another number cosine theta or sine theta. Okay, that one's a cardioid because the A and the B are equal. If I made this number smaller, so now if that's gone, there's a circle. Okay, if I put 1 plus in front, now it's an inner loop. If I changed it here, now it's dimpled, or excuse me, that one's convex to make it dimpled there. You'll see? So y'all can graph your different curves in Desmos on the polar grid. It just won't let you plot individual points. So that's what's different. Even when you have it graphed, if you try to go and like click on points like you do on a regular rectangular grid, it won't give you the coordinates. Like, so you can't go and see what these coordinates are. If you were to graph if you're supposed to graph something on paper and you're using Desmos as a guide to check yourself, you can pull it up here and look at it, but you still have to understand, okay, so I'm plotting this point. This point is at 7, 0, because it's 7 units out at 0 degrees or 0 radians. Okay, this point right here is at, you could call this 2 and 180 degrees, or 2 pi. Okay, so there's different, remember we talked about different ways to write those. Okay, so you still have to understand how to plot points because the calculator won't do that part for you. Cool? Okay, so now we are going to go into quizzes. We're going to play a little quizzes to check our understanding of polar equations. You can play on your laptop or you can play on your phone. And actually, I can stop the recording real quick. It just doesn't need to be recorded. That's the end of the notes. We're just going to do this check for understanding to finish out and make sure we've got the hang of this.